Get started. So this is one of the problems I got as a doubt on the other day from the previous assignment, that is YDSC. Let's do this problem, then we'll proceed to few problems in diffraction, then we'll start the next chapter. Okay. So the question is, there is a beam of light consisting of two wavelengths, 800 nanometer and 600 nanometer, that is used to obtain the interference fringes in a Young's double slit experiment on a screen placed 1.4 meter away. So capital D is given, and the distance between the slits is 0.28 millimeter, right? If the two slits are okay, calculate the least distance from the central maximum where the bright fringes of the two wavelengths coincide. So this is the central maximum. Let's say from the central maximum at a distance y, they are coinciding. So how to solve this problem? So we know the concept of fringe width, right? So fringe width is directly proportional to wavelength. Can I say this? Because beta is equal to n lambda into capital D divided by small d. Oh, sorry, it is lambda into capital D divided by small d. So the fringe width is going to be directly proportional to lambda. So in the distance y, which one will form less number of fringes? Will it be 800 nanometer or 600 nanometer?
600 nanometer.
600 nanometer will form less number of fringes. Will form but the answer is wrong. Because if you want more fringes to be present, see, I'm giving you a location, okay? Let's say I'm giving you a box. In this box, I'm giving you a small piece, okay, something. Let's say a piece of cardboard only again. I'm giving a piece of cardboard which has length L1, and I'm giving another piece of cardboard which has length L2. Tell me logically, within the same given box, which cardboard can you fix with more number?
L1.
L1. That is because the length of the width of it is less, right? In a similar way, if the width of the fringes is less, then more number of fringes can be formed within a particular location. I told you fringe width is less, but I never told you the number of fringes are less. Okay. So what will happen here is, if I say n fringes, listen. So here the answer is 800 nanometer will form less number of fringes. So with this idea, what I'm going to do is, y is equal to, since they want the bright fringes to coincide, so what is the formula for y? Y is equal to n lambda into capital D divided by small d. Okay. So in the case of first, if I say the nth fringe, that is when lambda 1 is 800, if there are n fringes formed in this gap, then when the value of lambda is 600, more number of fringes will be formed. So they will be able to coincide when the value of n is n plus 1 into lambda 2 into capital D divided by d. Okay. So we don't know what that n is. So if the nth bright fringe of 800 nanometer wavelength is at a distance y from the central fringe, then n plus 1th bright fringe of wavelength 600 nanometer will be at a distance y. It is exactly the next one. So since left hand sides are equal, we can write n lambda 1 into capital D by d is equal to n plus 1 into lambda 2 into capital D by d. So this and this will get cancelled. So n is, can I write 8n is equal to 6n plus 6, which implies 2n is equal to 6 and n will be equal to 3. Why I wrote 8n is because 800 and 600 zeros will get cancelled. So n is equal to 3. Means for wavelength 800 nanometer, there will be 3 bright fringes, and for 600 nanometer, there will be 4 bright fringes. So what are they asking? They are asking the value of y. So to find the value of y is equal to n into lambda 1 into d. So that is 3 into lambda 1 is how much? 800 into 10 power minus 9 because nano into capital D is how much? 1.4 the whole divided by 0.28. You solve this, you will get the answer.
Sir?
Sir,
Yeah, tell me.
sir, how 800 nanometer will form less number of fringes, sir?
I told no, this is the logic. Lesser the fringe width, more number of fringes. If the width of the fringe is less, that is 800 nanometer. If it is going to have a fringe width of this much value, 600 nanometer will have a fringe width of this much value. So when I take 800C, let us say this is the distance y. This I'm drawing a rough diagram for you to visualize. In the same distance y, what do you think will happen to green? You're able to understand? So if I'm able to allot 3 red spots between the distance y, then I'm able to allot 4 green spots because it is having lesser wavelength. Lesser wavelength, lesser fringe width, so more number of fringes.
Okay,
So
sir.
to conclude it, we can make you can write down because these kind of questions might come for MCQs. Write down the number of fringe width is the number of fringes will be inversely proportional to fringe width. Number of fringes will be inversely proportional to fringe width. Okay.
Sir?
Is anyone speaking?
I have one doubt, sir. Sir, I have one doubt.
Sri Sharan, are you speaking? I'm not able to hear.
Oh. Yes, sir, I'm speaking, sir.
I'm not. Your voice is breaking a lot. Can you put a message in the chat box?
Yeah, sir, I'll do that. Sir, but the
Okay.
chat
So
is...
this is the problem. Chat is disabled. Yeah. Now put.
Sir?
Yeah, tell me.
Sir, how did we get n plus 1, sir?
See, I'm saying if the nth bright fringe of 800 nanometer is going to go inside, so nth bright fringe, they're asking least distance. So if n red fringes are there, then n plus 1 green fringes will be there. That is what I meant. Because of the word least distance.
Okay, sir.
Yeah. Yeah. I hope it is cleared now. So I think other problems you could solve. We'll do some more. We'll do some problems from diffraction. Okay. So let's solve the first problem. Fraunhofer diffraction from a single slit of width. So it is the name of a scientist. You need not worry about it. Just have diffraction in your mind. So slit width is 1 micrometer is observed when a light of wavelength 500 millimeter, that is 500 into 10 power minus 3 is used. Calculate the half angular width of the central maximum. So sine theta will be equal to lambda divided by, just a minute. So sine theta will be equal to lambda divided by d. Lambda is how much? 500 into 10 power minus 3 divided by d is 10 power minus 6. So it will be 500 divided by 10 power 1 micrometer, right? So there is a mistake in the question. The wavelength cannot be in millimeter. It has to be in terms of nanometer. 10 power minus 9. So it will be 10 power 3. So 500 divided by 1000 is equal to half. So what will be the value of theta, guys? So if you just write theta is equal to lambda by t, then you will get it in terms of radians. Okay. Next. Light of wavelength 600 nanometers falls normally on a slit of width 1.2 micrometer, producing Fraunhofer diffraction pattern on screen. Calculate the angular position of the first minimum and the angular width of the central maximum. So how to solve this? So what is given in the question? Wavelength is 600 nanometer. The width of the slit is 1.2 micrometer, that is 1.2 into 10 power minus 6 meter. Calculate the angular position of the first minimum. So what is the angular position of the first minimum? The condition for first minimum is d sine theta is equal to lambda, which implies sine theta is equal to lambda divided by d. What is lambda, guys? 600 into 10 power minus 9 divided by 1.2 into 10 power minus 6. That will be 600 divided by 1.2 into 10 power 3. That is 600 divided by 1200. Answer will be 1 by 2. So theta will be 30 degrees. So that is the first angular position. And they're asking the angular width of the central maximum also. Angular width of central maximum is what? Two times angular width of any other maximum or minimum. So 2 into 30 degrees, it will be 60 degrees. Okay. Next. I hope these are all clear, right?
Yes, sir.
Yes, sir.
So microwaves of frequency 24,000 megahertz are incident normally on a rectangular slit of width 5 centimeter. Calculate the angular spread of the central maximum of the diffraction pattern of the slit. So lambda you can calculate. So they've asked what have they asked? They have asked the angular spread of the central maximum. So you know the angular spread 2 theta is equal to lambda by d. We can directly go with this. So 2 theta is equal to what is the value of lambda, guys? So what have they given? They have not given the wavelength, rather they have given frequency. So distance is equal to speed into time. So c divided by f. F will be equal to, or lambda will be equal to c divided by f. C divided by d into v. So 2 theta is equal to 3 into 10 power 8 divided by d is how much? 5 centimeter. 5 into 10 power minus 2 into v is f. So what is the frequency? It is 24,000. No? 24,000 into 10 power 6 hertz. Once you calculate this, you will get the answer. So 3 zeros means it will be 10 power 9. So 3 into 10 power 8 divided by 5 into 24 into 10 power 9. So 10 power 7, it will get cancelled. 8, 1 divided by 40 is 2 theta. Did I make any calculation mistake?
Sir, it is 10
Numerator
divided by
as
40.
10.
Sorry, where? Ma?
10 divided by 40, sir.
Oh. 10 by 40. Now is it fine? Yeah. 10 by 40. So 1 by 4. But still it is not coming as half radian. They've asked the angular width of the central maximum. So 2 theta is equal to, what else is missing? Oh, sorry. 2 theta is equal to 2 times lambda. 1 minute. See, 2 theta is equal to 2 times lambda by d. No? I forgot a 2. So this should get multiplied with 2. This will, there will be a 2 here. 2. So 2 into 10. So 2 theta will be equal to half. So half radian is the answer. I hope you guys understood. So I used a wrong formula. 2 theta is equal to 2 into lambda divided by d, and lambda is equal to c divided by f. These are all the formula that we used. Okay. So we'll do one last problem, then we'll go to the next chapter. So in diffraction, this is how the problems will be. Fourth, a slit of width d is illuminated by red light of wavelength 6500 angstrom. For what value of d will the first minimum fall at an angle of diffraction of 30 degrees? Okay. So what is the condition for first minimum? Condition for first minimum is d sine theta is equal to lambda. So d is what we need to find. So sine of, this is first minimum is falling at an angle of 30 degrees is equal to lambda. Lambda is what, guys? 6,500 into 10 power minus 10 meter. 1 angstrom is 10 power minus 10. So D will be how much? 13,000 into 10 power minus 10 meter, or it will be 1.3 into 10 power minus 6 meter, or 1.3 micrometer. Similarly, second part of the question, you guys tell me, what should be the value of D for which the first maximum falls at an angle of diffraction of 30 degrees? So what is D sin theta is equal to? Condition for first secondary maximum. When they say first maximum, it is a first secondary maximum.
Three lambda by 2.
That's right. So D into sine 30 is equal to 3 into what is the value of lambda, guys? 6,500 again into 10 power minus 10, the whole divided by 2. So this will be 3750. So D will be 3750 into 2 into 3. Actually, I could have cancelled the 2. So it will be 6,500 into 3 into 10 power minus 10. So is it 195? 19500 into 10 power minus 10, 1234. So it will be 1.95 into 10 power minus 6 meter, or 1.95 micrometer. Clear? So these are all the problems that are related to diffraction. The remaining problems, I'll upload it today. You can try them as homework. Any doubt, you can ask me in the next class. So with this chapter is over actually. Okay, polarization concept is removed this year. So as it is independent, I'm leaving it. So we'll start the next chapter, okay? Just give me a minute. So now we'll start. I hope you're able to see my screen. Right. So in your second volume, if you see, in your second volume, the first chapter that we dealt with is ray optics. And the second chapter that we dealt with is wave optics. Right. So 1 minute, wait.